Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, we're going to talk about handling exceptions that occur within your application. We'll discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashing through the use of the try-catch block in C#. So when the compiler catches a data type mismatch, an unresolved reference to a class, or some malformed C# instructions, it will refuse to compile your source code into a .NET assembly until you fix the problem. These types of problems are called compilation errors. However, there are other types of errors that happen during runtime, or in other words, they happen when the compiled .NET assembly is actually in the act of executing. There are countless reasons why this could occur, but many times it occurs due to situations that are outside of the control of the developer. For example, if your application cannot read or write to disk because a folder or a file is missing or it's corrupt, or because network access to that resource is unavailable, or when attempting to access a database, perhaps the table is not there anymore, or the structure of it has changed, or just otherwise unavailable. These could all cause your application to experience an exception at runtime. Now, in some cases, the developer may not have foreseen a problem and therefore didn't account for it. For example, perhaps the developer allows users to type in a country, but the user misspells the country name, or perhaps the user maliciously types in numbers instead of alphanumeric characters or alpha characters. So as a software developer, your job is to make sure that you account for these possibilities. A friend of mine was fond of saying that 80% of all code exists to solve 20% of all potential problems that happen in your code. So generally, software developers should be pessimistic of the reliability of all outside input to the program. So if you rely on a file or a network resource, treat it with great suspicion. If you rely on a user to type in data to your application, then treat it as if it is absolutely evil, okay? So this is the software developer's equivalent to defensive driving. Always code defensively. And the way that a C# developer codes defensively is through the use of a try-catch block, which we'll demonstrate in this lesson. Okay, so what I want to do is actually go back to the read text file while project that we created back in lesson number 7. So I'm just going to use the recent link here. If it doesn't show up, you can always go to File, Open Project, and then scan through your projects folder to find the read text file while project. All right, there we are. And just want to confirm that it actually still works. It does. Great. So now what I want to do is I want to actually sabotage the application by changing the name of the file. There's a couple of different ways I could do this. I could change the actual name that I'm looking for itself, but I want to show you one other thing that you can do with the Solution Explorer, and that is to right-click and select Rename. And here we'll just change the name from values.txt to values1.txt. Then I'll hit the Enter key on the keyboard to actually make that change permanent. All right, so now whenever I run the application, let's see what happens. Here's what a developer sees whenever you encounter a runtime exception. An unhandled exception of type system.io.file-not-found exception occurred in the mscorelib.dll. Couldn't find the file, and then gives the actual the location that it was and the file name that I was looking for. All right, so that's what a developer sees when running this in Visual Studio. But what would an end user see whenever they encountered this exception? Well, remember the technique that we used several lessons ago whenever we created a release version of our application? You want to make sure that to choose the release configuration and then choose the build solution. And then what we want to do is open up Windows Explorer and confirm that we actually have a bin/release folder. So we'll go to Visual Studio 2013 Projects, read text file while, look in the project folder, in the bin folder, then in the release folder. And we can see here we have both our .exe file, our application, as well as the values1.txt file. So when I double click the .exe file, and make sure you're working with the application. Sometimes Windows Explorer is set up to not display common file types, the extensions for common file types, so it might leave off the .config, and then you think you're clicking on the read file while .exe when you're really just opening up the XML configuration file. All right, I've done that before. All right, so let's double click this, and right away you see an error message pops up. Another error message in Windows pops up with the read text file while has stopped working. A problem has caused the program to stop working correctly. Windows will close the program and notify you if a solution is available. So we have a mess going on here. And this is what you want to protect your end user from actually seeing whenever they work with your application and experience a runtime error, runtime exception. So what we want to do is fix this problem. And to fix it, I'm going to add a try-catch block around most of the code in the application. And so to do that, I'm going to go right above the stream reader and then right below the myreader.close, and I'm going to insert the try. I'm going to remove that curly brace and insert it down here instead. And when I put the try, open curly brace, close curly brace, everything in the middle moves over just a little bit, indents. So that lets me know that I'm doing it correctly. But I'm not just done yet. What I want to do next is add a catch. All right. And so anytime an exception happens, we want to catch it and write this code instead. Console.write line. And I'm going to give it just a real simple message, something like, something didn't quite work correctly. All right. Now, ideally, we'd give it a much more meaningful error message, and we'll come back to it and add one in a little bit. Ideally, we would give a little bit more information, help the user debug the problem on their own, but in this case, we just want to start simple. Let's go ahead and run the application now, and when we do it, you can see that we catch the exception, we run this catch block of code, display this console message to say, something happened, it was a problem, but at least they don't see the error message, right? So that's an improvement. We can take this one step further by actually catching the exception, and to catch it, we will create an input parameter of type exception. So exception E, catch exception E, and then here what we'll do is we'll actually display the exception, and there's a lot of information that we can retrieve about the exception. We can get, for example, the source. We can view the entire stack trace, which is the call of one method to another method to another method to kind of see what was the sequence of events that led up to this exception. We can view any inner exceptions, so smaller exceptions that bubbled up to create a larger exception, and any data and things of that nature. But what we want is just to print out the actual message itself. So let's go ahead and run the application again. This time we see something didn't quite work correctly, and then we see the reason why, the message why it couldn't work. It could not find the file, and then it gives the long list of the path and then the actual values.txt file. Now an observant user might inspect that and look it over and say, hey, I wonder if that values.txt file even exists in the location where it says, and so they might, navigate down into that path and look and say, oh yeah, values.txt doesn't exist, but values1.txt does exist. That's the problem. And maybe they're smart enough or clever enough to actually fix the problem by just renaming this file. That's a lot to ask. So what we might want to do is actually take another tact, and that is to give the user as much information as possible so that they can fix the problem themselves. So to do that, what I want to do is rework this this code example. Now, to rework the code example, we're going to need to know the type of exceptions that our application can throw. In this case, if you hover your mouse cursor over the stream reader, the data type, you'll get a little bit of information, but if you hover your mouse cursor over the actual constructor, the one where we create the new stream reader, open and close parentheses, you can see that the number of overloads that are available, and then the number of exceptions that can occur in the constructor. All right, and so there are, for example, argument exceptions, argument null exception, file not found exception, directory not found exception, okay, and then just general IO exceptions. And we can look up each of these in MSDN like we did previously and learn a little bit more about the conditions that prompt these exceptions to actually flare up and happen. So what I'm going to do is just I'm going to take this tact. I'm going to rewrite this, and I'm going to look for some of those very specific exceptions first. And if we can kind of filter down the list of possibilities, we'll get to the point where we just catch this general exception. Something bad happened. Here, figure it out on your own. So you'll see this in action. Let me just get started here with a catch. Exception. Whoops. Let's go directory not found exception E. So then we'll do console.writeLine. Couldn't find the file. Are you sure the directory exists? All right. Then we're going to catch file not found exception E. We're going to console.writeLine. Couldn't find the file. Are you sure you're looking for the correct file? Okay. And then finally we'll have that exception E there. All right, so in order to break this correctly, I'm going to have it start by looking in a subfolder called boo. And I know boo folder does not exist. So what I'm trying to do is trigger this first exception happening. So let's go ahead now and run the application. And this time it says, I couldn't find the file. Are you sure that the directory even exists? Well, no, it doesn't exist. I know that to be the case. Now let's see if we can get that second one to happen. So let's remove the boo directory and start it again. Couldn't find the file. Are you sure that you're looking for the correct file? All right, and so that might lead the user to look for the values.txt. Maybe we could give a better error message there. And then finally, if something else went wrong, this final exception would finally would kick in. All right, so the key is to check for the most specific exceptions first and the most general or generic last. So we begin by catching the most specific, a directory not found, and then a file not found, and then move on. All right. So there's one other part to this try-catch block that I want to add, and that is finally. All right. And so let me just type in this little message. All right, great. All right, so as you can see here, you want to use the finally to wrap things up. So if there was some way to close a connection, deal with with the fact of the matter that you can't get to the resource that you need to, think about the logic that would leave the data in an incorrect state and then address it here in the finally. Okay, so that's the purpose of using that, and you want to try to clean up as much as you can before you move on. All right. Now, as we look over this structure, this try, catch, 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 and then finally, on the surface, it might seem to make sense to you to just wrap your entire application in a try-catch block. But frankly, that's a little bit lazy. Some developers have done that, but they're often ostracized by end users for providing these cryptic error messages. I mean, just think if we were to just leave these off and just rely on the exception E, and then something didn't work, figure it out for yourself. All right, that's a little bit lazy. So typically, you'll see some error messages that no human except maybe the guy that actually wrote the application could even understand. Well, the reasons developers do this is because they sometimes take that exact approach, leaving exception handling to the very end of the software development process. And so that leads to this catch-all that's convenient for the developer, but it's maddening for the user. And I'm sure you've been there and seen those maddening error messages before. So you should strive to put the same amount of attention into protecting your user from having to guess what to do next or how to fix the problem. If you, the developer, can fix the problem for the user without the user knowing it, awesome. You should do that. If you can't, well, at least identify the exact problem and then ask the user for input that you might need to handle that situation gracefully. You should protect the end user from losing data or feeling stupid at all costs. That's what makes your application polished, and it's what users expect, a reliable experience. No surprises. All right. So to recap in this lesson, we talked about defensive coding through the use of the try-catch block, to plan for inevitable problems that come as a result of trusting anything that's exterior to your application. We talked about handling special cases first and then more general cases last. And we talked about the mindset of the conscientious developer who seeks to advocate and protect the user from losing data and from even having to make tough choices or from feeling dumb while they're using your application. Using a catch-all strategy like just catch exception E is not ideal, and you should strive to examine each part of your application that relies on exterior resources like we did here when we hovered our mouse cursor over the constructor for the stream reader, and then apply a try-catch block judiciously around those parts of your application that rely on those external resources. All right? Awesome. We are making great progress. You're doing great if you're hanging in there with me. We're almost to the end. Don't give up now. We'll see you in the next lesson. Thank you.